Two yellow eyes catch the last light of the day, and they are staring directly at you. A cave lion, twice the size of anything wearing that name today, closing the distance in complete silence. 700 pounds of muscle, claw, and teeth, built by millions of years of evolution for exactly this moment. You have no gun, no knife, not even a sharpened stick. Your nails are useless. Your teeth are flat. You cannot outrun it. You cannot outclimb it. You cannot win a fight against it. So how are you still here? How did your ancestors survive an entire planet that seemed engineered specifically to kill them? The answer does not start with strength, because your ancestors never had any to speak of. In 1924, Raymond Dart uncovered a skull in South Africa that changed the entire conversation. It belonged to a child, an early human ancestor, roughly 3 years old at the time of death. Punched clean through both eye sockets, 2 holes spaced with chilling precision, matching a leopard's lower canines exactly. Dart proposed his interpretation almost immediately, and the scientific establishment of his era rejected it almost as fast. The dominant theory at the time insisted early human ancestors must have been hunters first, killer apes shaping tools and dominating the landscape from the very beginning. A small, defenseless victim did not fit that story at all, so for decades, Dart's specific reading of the evidence was pushed to the margins, treated as speculation rather than fact. It took new excavations, new bite mark analysis, and comparisons against known predator jaw structures gathered slowly across the following decades before the wider scientific community finally came around to what the puncture wounds had been saying from the very beginning. This was not an accident. This was not unusual. For millions of years, humans were not hunters. They were hunted, and the predators waiting for them were not ordinary animals. They were apex killers, refined over millions of years. Start with Smilodon fatalis, the saber-toothed cat, 11-inch canines, 600 pounds, built like a living tank. It did not chase, it ambushed, exploding from tall grass to puncture the throats of bison and camels in one strike. Then came something even larger, Arctodus simus, the short-faced bear, the biggest land predator North America ever produced. 12 feet tall, standing upright. 2,000 pounds. A hypercarnivore, eating meat exclusively, capable of running 40 miles an hour. If it saw you, you were already dead, and there was no version of that sentence that ended differently. Cave hyenas prowled the same landscape, larger and stronger than their modern relatives, with a bite force of 1,100 pounds per square inch. For comparison, a human bite manages roughly 160. A cave hyena could crush solid bone to reach the marrow inside. Dire wolves hunted in packs of 30. Cave lions, 25% larger than modern African lions, hunted in coordinated groups too. Many of these predators hunted specifically at night, exactly when early human eyesight was at its absolute weakest. Now compare all of that to what humans actually brought to this fight, biologically speaking, and the numbers get worse. A chimpanzee, our closest living relative, is roughly 3 times stronger than an adult human, and chimps still lose to leopards regularly. Humans were slower than chimpanzees, weaker than chimpanzees, terrible climbers by comparison, and dangerously loud even as infants. A human baby could not walk for an entire year after birth, and screamed loudly enough to be heard from a significant distance. By every conventional biological measure available, this species should have gone extinct within 100,000 years, easily. It did not. And every single predator just described is now completely gone, every one of them without exception. So what changed the outcome so completely, against odds that heavily favored total extinction? The first real answer is fire, and the evidence for it goes back further than almost anyone expects. At Wonderwork Cave in South Africa, archaeologists uncovered evidence of controlled fire dating back a full 1,000,000 years. Burned bone, layered ash, defined hearths. This was not an accident. This was a tool, deliberately maintained, A lit fire creates a rough 30-foot safety radius that most predators refuse to cross, almost as if hardwired into their instincts. Even today, African lions instinctively avoid open flame, a behavior clearly inherited from an extremely long evolutionary memory. Fire gave early humans light in total darkness. Warmth their hairless bodies were never designed to survive without. Most importantly, fire gave them something no predator ever anticipated needing to fight against: extra time. Before fire, sunset meant finding shelter and staying frozen in place until morning arrived, no matter what. After fire, humans gained 3 to 4 extra usable hours every single night, hours that changed everything that followed. Time to shape tools by firelight. Time to cook food. Time, for the first time, to simply sit and talk. And cooking mattered enormously on its own. Cooked meat delivers more calories and digests far more easily than raw meat. More available calories meant humans could finally afford to grow something metabolically expensive: a significantly larger brain. A larger brain meant better problem solving, which, eventually, meant better odds of surviving the exact predators still hunting them. But fire alone was never going to be enough to survive every single threat roaming that landscape. The second weapon was endurance, and it remains one of the strangest advantages in the entire animal kingdom. Humans are terrible sprinters. A saber-tooth could hit 30 miles an hour in 3 seconds flat, no contest at all. Humans top out around 18 miles an hour, and only for a short, exhausting burst before collapsing entirely. But no predator on the list could do the one thing humans could sustain for hours without stopping: distance running. This is called persistence hunting. You do not chase an animal at full speed. You track it steadily, at a jog, fast enough to keep the animal moving, never quite letting it stop, rest, or recover its strength. Because humans sweat, they regulate body temperature while running, an ability most other mammals simply do not share at all. Eventually, the prey overheats and collapses from exhaustion, while the human pursuer barely breaks a difficult stride. This single, strange advantage drove both the hunt and, indirectly, the long-term survival of the entire species. The third weapon operated inside the skull rather than the legs: pattern recognition, sharpened generation after generation. Human brains evolved to notice patterns almost obsessively, storing observations that could later mean the difference between life and death. Cave lions hunt at dusk. Cave lions avoid fire. Short-faced bears are solitary, territorial, and best avoided entirely. Someone observed these patterns firsthand. Someone remembered them. Someone taught them to the next generation around a fire. And every single generation after that added its own layer, compounding fragile individual knowledge into something closer to shared wisdom. Around 400,000 years ago, that accumulated knowledge produced spears, crafted with real skill in what is now Germany. Thrown from a distance, a spear became something no predator on the continent had ever evolved to defend against. 5 humans, armed, coordinated, and patient, stood a genuine chance of killing a saber-toothed cat outright. And they did exactly that, repeatedly, across thousands of years, in ways the fossil record still quietly confirms. But the detail that changes this story completely is not fire, or endurance, or even the spear. It is a single skeleton, discovered decades ago, belonging to an older adult who had lost every tooth years before death. No teeth means no ability to chew raw meat, no ability to process tough, unprepared food without serious help. And yet this person lived for years afterward, reaching roughly 40 years old, an advanced age for that era entirely. Someone had to be feeding them, chewing food for them beforehand, or cooking it soft enough to eat without teeth at all. This person had severe arthritis too, could not hunt, could not fight, could not meaningfully contribute to daily survival labor. And the group kept them alive anyway, for years, with no immediate practical return on that ongoing investment. That decision is not cooperation in the narrow, transactional sense most people assume when they hear the word. Cooperation can simply mean working together toward a shared, practical goal, The way wolves hunt in a coordinated pack. This was something else entirely. Care extended towards someone who could no longer offer anything measurable back in return. No predator on that entire list ever evolved anything resembling this behavior, and none of them needed to. A pack of wolves does not carry an elderly, toothless member for years out of simple sentiment. A pride of cave lions does not feed a member too injured to hunt, indefinitely, at real cost to the group. But somewhere, in a small human band surrounded by animals built specifically to kill them, someone made exactly that choice. And it did not happen once, as an isolated act of individual kindness lost quickly to time. Archaeological evidence for this kind of care appears again and again, across sites, across regions, across enormous stretches of time. This suggests something structural rather than incidental, a group norm, quietly enforced generation after generation, without needing to be written down. Evolution handed every single predator exactly one specialized advantage: raw speed, overwhelming strength, venom, or perfect natural camouflage. Evolution handed humans something categorically different: adaptability, expressed not only through tools but through care itself. Consider what that actually means, set directly against the raw statistics listed earlier in this exact story. 11-inch canines could not evolve a defense against a spear thrown from 20 feet away by someone with a plan. 1,100 pounds of bite force could not evolve a defense against a species willing to feed its own weakest members for years. 40-mile-an-hour speed meant nothing against a species that simply refused to stop moving until the prey collapsed first. None of these predators could evolve a countermeasure for compassion, because compassion was never a threat their instincts were built to recognize. Consider for a moment how researchers even arrive at a specific figure like 6 to 10% for predation deaths, because the method itself tells you something about how careful this kind of science has to be. Paleoanthropologists examine fossil assemblages for exactly this kind of forensic detail. Puncture spacing that matches a known predator's jaw, drag marks consistent with a carcass being moved rather than left where it fell, tooth-scored bone that could not have come from scavenging alone. Each individual case proves relatively little on its own. A single punctured skull could theoretically be an unusual accident. It is the accumulation, case after case, site after site, across enormous stretches of time and geography, that turns individual oddities into a statistically meaningful pattern. That accumulation is also why scientists remain cautious about the exact percentage. Fossils are rare to begin with, and the ones that survive with this kind of damage intact are rarer still. The real historical rate could plausibly sit somewhere above or below the commonly cited range. And researchers are honest about that uncertainty rather than presenting a single number as beyond question. What does not appear to be in serious dispute is the underlying pattern itself. Early hominins were, for an extended stretch of their evolutionary history, meaningfully vulnerable to large predators in a way modern humans simply are not, and that vulnerability shaped behavior long before it left behind anything resembling a written record. Now return to where this story began. Standing in tall grass, facing two yellow eyes reflecting the last light of day. That moment was real, repeated countless times, across tens of thousands of years, against odds that should have ended everything, and yet the outcome, replayed across an entire planet, was always strangely consistent in the end. Saber-toothed cats vanished roughly 10,000 years ago. Cave lions, 14,000 years ago. Short-faced bears, 11,000 years ago. Dire wolves, cave hyenas, giant sloths, terror birds. Every name on this list is gone completely from the modern world. Paleontologists who specialize in ancient carnivore ecology, including researchers like Blair Van Valkenburg, have spent years untangling exactly this question, comparing tooth-wear patterns and population densities across these vanished predator species. Historians still debate exactly how much of that extinction traces back to humans and how much to shifting climate alone. But the pattern repeats itself on every single continent humans ever reached, with almost eerie, unmistakable consistency. Every apex predator that once treated humans as easy prey is gone. Only the prey species is still standing. Not because that species became the strongest animal in any given fight, measured claw for claw or tooth for tooth. Because it became the only animal willing to carry its weakest member for decades, expecting absolutely nothing measurable in return. That single trait, invisible in any raw statistic about speed, strength, or bite force, turned out to be the deciding one. Every predator on that ancient list was optimized entirely for killing efficiently. Humans, quietly, almost by accident, optimized for something else no predator ever saw coming, refusing to let each other die alone.